Hello everyone, I will give a brief introduction to this review. Our review is about the latest research advances in the oral microbiome in the last 3 years and summarizes the trends as an important shift from technology-driven to hypothesis-driven. The microbiome is in a symbiotic relationship with the host. Among the microbial consortia in the human body, that in the oral cavity is singularly complicated, with the second greatest diversity. Dysbiosis of the oral microbiota can cause oral diseases and even systemic diseases. Due to the lack of specific driving factors for some diseases, scholarly attention is drawn to oral microorganisms as potential risk factors. Around 2000, with the advent of next-generation sequencing technologies, a large number of sequencing-based microbiome studies emerged, as we can see from the graph that the number of papers on oral microbiology has reached an unprecedented level. This is admittedly a breakthrough in human oral microbiology. Although technological developments in the field of genomics have undoubtedly driven the process of oral microbiology research, it seems to have reached a bottleneck. We believe that we are at a critical turning point of global trend naturally from technology-driven to hypothesis-driven. Let me first explain the concepts of technology-driven and hypothesis-driven. Technology-driven studies refer to descriptive ones. That is, the study utilizes next-generation sequencing (NGS) technology to obtain a microbiological portrait of a specific population, and then describes it. Designing experiments to validate and thereby derive causality is called hypothesis-driven research. This review discusses our perspective in detail around this shift. In the technology-driven section, we summarize research progress in 5 aspects. The first is the expanded database, including a new taxonomic-level superspecies, some new unculturable bacteria, and the use of macrogenomes to assemble these unculturable bacterial genomes. We then describe the advancement of new genomics technologies and methods for oral microbiology research, such as advances in 3 key technologies: microarray, multiomics technologies, and machine learning. We also highlighted the promising hypothesis-driven approach of germ-free mouse transplantation. The exploration of new study populations is described at 2 levels: microbiological differences that have not yet been explored or confirmed conclusively, and the interpretation of these differences. For the description of diseases, we mainly address diseases that have progressed more recently, or oral microbiological differences in different immune states. Finally, we also list some new diagnostic tools and models proposed by large-scale studies as a way to explain specifically what is the standardization process of macrogenomic studies. Hypothesis-driven studies often have greater clinical significance because they are grounded in a defined starting point. We focus on oral microbiomic studies in mechanisms of pathogenesis and disease therapies. In the mechanism section, we focused on 2 currently controversial hypotheses, namely periodontal self-driven inflammation spreading systemically, and bacterial transmission in the oral intestinal axis, to discuss which is the more powerful hypothesized mechanism for systemic disease. The ultimate goal of exploring oral microbiology in healthy and disease states is to look ahead to future pharmacological treatments. Here we focus on the therapy of intestinal inflammation and cancers, also focusing on the side effects and complications of cancer therapy. Genomic studies, based on these hypotheses, provide new value for disease therapy. Let's go back to this page for a quick summary. The most critical aspect of technology-driven research is the lack of clear assumptions before beginning. While it is important to explore blanket areas, technology-driven studies can also lead to conclusions that are useless, contradictory, or lack clinical relevance. In contrast, hypothesis-driven studies are more clinically relevant because they are grounded in a certain starting point, taking genomic evidence further to test one or more hypotheses. In fact, this change is the result of researchers fleshing out and clarifying the purpose of their studies, building on the vast database accumulated over the last 2 decades. The formulation of new scientific questions and hypotheses will accelerate this new research process. Therefore, the next phase of the global research process necessitates hypothesis-driven rather than technology-driven microbiome studies. To the best of our knowledge, this classification is being proposed for the first time, and such a cutoff can clearly demonstrate a major shift in the direction of oral microbiology research. The purpose of this review is to guide researchers who want to approach the study of the oral microbiome in the most recent and effective way, to speed up the process of oral microbial research.